Okay, so now let's verify our requirements that we can do the confidence interval that we've already done. So we know that the data set was random because they told us right here that it was a random group of swimmers. So that was yes given. The new piece is the dependent sample, but we already said what this was. This was one group of swimmers measured twice. So that's a yes. All right, then we need it to be independent of the population. All right, so we need little n to be less than 0.05 capital N. If you want to think of it as the differences, that's fine. It doesn't really matter. Little n for differences was 12, right? That's the sample size. And that's less than 0.05 of all swimmers in the world, right? Even all competitive swimmers. There's a lot of competitive swimmers out there. So this is a yes because it's one group measured twice. This is a yes because 12 is less than 0.05 of all swimmers. This piece with the dependent is the new piece for this chapter. Everything else we've done before. And then normal is what the graph is for, because you'd like n to be bigger than 30, but it's not. But these points are linear, right? They're kind of clustered along that line. So the points are linear with no outliers. All right, so that means that the interval we created is valid. So let's go get the values for it. It was right here with the lower and the upper. So it's 0.0637 and 0.0913. And that's meters per second, right? They're going that much faster, right? Because it's talking about their maximum speeds that they achieved in these swimsuits, right? In the regular swimsuit versus these fast swimsuits. All right, so now we want to find the point estimate of the difference. Okay, so remember the point estimate of the difference is right here. It's d bar, which we've already found, right? So the point estimate of the difference is d bar, which would be the value we found on the previous page, 0.0775 meters per second. We think that there's an average of 0.0775 meters per second difference in the speed of these swimmers. That's the one way to find it. Now the other way to find it, because it does say to give it two different ways, that would be the old school way, where we would take the lower plus the upper and divide by 2. Right, so let me separate my paper here. Okay, so the lower plus the upper would be 0.0637 plus 0.0913. You add them up and divide by 2, and let's see what happens. Let me go grab Desmos. I'm going to hit division first, so that way it makes the, 0.0637, there you go, plus 0.0913 and divide by 2. So I put the division first, so that way it made the fraction all joined up. I put the two pieces on the top together. The other way to do that is with parentheses up top. And we get 0.0775, just like we did when we did it with the definition. So I only had us do it two ways just to kind of be a little review. So this is a review from earlier chapters and earlier sections. And the units is meters per second, because this is their top speed. Okay, what about the margin of error? Well, there are two ways to find that also, but our most common way, if we have the interval, is to take the upper minus the lower divided by 2. All right, because the error is the distance from the outer edge to the center, right? So 0.0913, in other words, it's half the width. So we take the whole width from the lower to the upper, we subtract, and we divide by 2. All right, so let me hit another division here. So 0.0913 minus 0.0637 divided by 2, and we get 0.0138. And again, that would still be meters per second, right? It's whatever your data set's units are the units for these values. Right? Okay, so interpret the confidence interval in the context of the situation. Well, we are 95% confident, right? The script hasn't changed from chapter 9, that the true, and I just wanted to grab the script. It's this script right here from chapter 9. It's just that the population parameter is different. It used to just be proportion or mean, and that was it. And then the last section we saw a difference in proportions, and this is actually the mean of the differences, right? So it's the true mean difference, or average difference, if you want to say it that way. You could also say average. Difference in swimmer's maximum velocity, in the swimmer's, right, the fastest they swam the whole time. Swimmer's maximum velocity is between, oh, I'm going to have to put it here, is between 0.0637 meters per second and 0.0913 meters per second. Sorry, that got a little strange. I guess I'll put the between right here. I take it back. Okay, so does that mean that there is a difference? Okay, so remember how this picture works. You have a confidence interval. The lower number is over here at 0.0637. And you're 95% sure that it's somewhere between here and here. And this is 0.0913. And just a little review, this is the point estimate in the middle. That was the 0.0775. And the error is this distance right here, which was 0.0138. And also this distance. Just a little review of that picture. So we're 95% sure it's in there. But what is not in there is 0. 0 is lower than all of these numbers, right? It's lower than the lower number. Okay, so remember that the H naught would be that the mu d equals 0, that there's no difference in the groups. All right, but if 0 is not in the interval, that means that there is a significant difference. So yes, the interval suggests that there is a significant difference. Because, so does this interval suggest there is a significant difference? Yes. And if you want to write there is a significant difference, we could say that. Interval suggests a difference. A lot of times we don't write that piece because it's already implied in the question, but if you want to write it, right, yes, the interval suggests there is a significant difference because 0 is not contained in the interval. 0 is not between your lower and your upper. And that's a review of something we already saw in the previous section. If you're going to show that there's a significant difference, then you have to have 0 not in the interval. Right? It cannot be 0 between your lower and upper. Right? That's what it means by in the interval. So it cannot be 0 cannot be between the lower and the upper. Right? If that's the case, then there is a significant difference.